Part 5 is complex correlations. We're going to, in an ideal world, we'd look at all three of these, but for our content today, we're going to stop at correlation matrices, and we'll see if we move on to partial correlations and regression models next time. So, in many studies, correlations are calculated not just for one pair of variables, but for lots of pairs of variables. And this creates what we call a correlation matrix, in which correlation coefficients are presented in a grid. You'll see that the same variable names are recorded in the top row and left column, and correlations between those variables are recorded in the corresponding cell. So usually when you see this wouldn't comprise the whole study. This would be like descriptive data showing who are the individuals that participated in the study. So I'm going to skip this one for now. So in this slide, you can see that we're looking at 4 variables. We have need for cognition, intelligence, social desirability, how much they want to be seen as socially desirable, and dogmatism. These terms are defined over here. So social desirability is the tendency for individuals to respond in socially acceptable ways. They want to be socially desirable. And dogmatism means that they tend to grasp on to things that they believe in and not listen to other people, just be kind of close-minded about it. And you can see that each of these variables is listed in a corresponding place on the side. So need for cognition first, intelligence second, social desirability third, and dogmatism last. You'll also notice that a lot of the cells are empty and there are dashes going down the middle. So the dashes correspond with each variable's correlation with itself. And because this is the exact same score, these will always be 1. Need for cognition just has 1 score. So if we take the values for need for cognition and we list them for individual, and then we do it again, they will be perfectly correlated. The same for intelligence. So these blanks, these dashes here, just mean these are perfect correlations. Obviously, intelligence is linked to intelligence. Social desirability correlates perfectly with social desirability. And so the data of interest is these showing the relationships between these 2 measures. So the relationship between intelligence and need for cognition is 0.39, a positive correlation. As intelligence goes up, need for cognition goes up. You can see that dogmatism, or rigid grasping onto principles, decreases as need for cognition increases. At a negative, sort of a low to moderate effect or a weak to moderate effect, minus 0.27. Dogmatism decreases as intelligence increases. And none of these have much of a relationship to social desirability. You might wonder why these cells are blank, and it's simply because it would make it too busy for your eye. So we could fill these in. The relationship between dogmatism and need for cognition is going to still be minus 0.27, so we could fill it in. It'll be the same as it is here. The relationship between intelligence and need for cognition is going to be the same, so we could fill it in here and put our 0.39. But that would make it pretty busy for the eye, so usually just 1 set is listed. So if we look at this correlation matrix, we can see that it's very similar to the previous one, except that they listed out the ones in the middle. So here they go. All these are listed. They're correlations of 1. Happiness correlates perfectly with happiness. We can see that they used 4 digits. So we're looking at kind of a busier data set. I prefer 2. And these little asterisks at the end, these mean that this was statistically significant. So this positive correlation between job satisfaction and happiness was at the 0.86 level, very strong and statistically significant. Once again, they left this top part of the grid blank so we don't overtax our visual system. And hopefully this all makes sense. So for the last correlation matrix we'll look at, we see that in this case, the whole matrix is filled in. So you can see that the ones are written in going down the center, the perfect correlations with each variable with itself. And then you can see here that the other variables are written in 2 locations. So the relationship between exam score and hours spent studying is shown here as 0.82. And it's also shown here as the same 0.82. It's written twice. Hours spent sleeping corresponds inversely with hours spent studying. As sleep goes up, studying goes down. And you can see it's listed here as minus 0.22, a weak negative correlation. And also, if we follow hours spent studying across, we can see it also right here, this minus 0.22. So in the matrices that we've looked at, typically this part has been left blank and kind of darkly shaded in. See if I can get the pen to do that for us here. Sort of crossed off, right? Left blank. And in some of them, even these center cells, the ones, weren't presented. All of that because it's redundant. It's not necessary. It's what we already know. It's what the only thing it could be, or it's just a duplicate. And this is the key information that's often presented. So hopefully that helps you understand correlation matrices. I'll encourage you to watch the video from class as well, especially on the section called Measuring Correlations. Thanks for tuning in. So a partial correlation then can give us a lot of information, not just about the predictive power or the relationship between two variables, but the relationship among several variables. So in this example, we can see the pink is exercise, the yellow is weight loss, and the blue is diet. So this area in which all three overlap is the proportion that expresses the relationship between the three of these as they impact an outcome variable. So these three co-correlate. So if you can imagine taking this amount out of the correlation equation, then we can see that a couple things. We can see the independent impact of each of these variables, and we can also see the extent to which these two pairs of variables overlap in each of these directions. And so it's good to know a relationship between two variables after controlling for a third variable. It just gives us more information about the nuanced relationships among these variables. Next, we talk about factor analysis. And so there are a few slides on this. And so I'll just start by saying many of the personality inventories that you get, in fact, always use a statistical process called factor analysis. And that's how they identify which items or which statements on the questionnaire are going to cluster together to be good indicators of a construct of interest. So let's look at some examples. So this is a really simple example. Imagine that we wanted to have restaurant ratings and we had all of these variables that we were measuring, but we wanted to make the information a little more concise. So what we might find is if we entered these 6 factors into a statistical program, that the scores that were high on this variable would tend to be high. So if the taste of food tended to be a high score, and food temperature tended to be a good score. The food temperature was good and the freshness of food was good. If someone responded positively to one of these, they would tend to respond positively to all 3 of these. And so then responses on these items would cluster together. And then the researcher, seeing that the statistics showing that these items are tending to vary together statistically, might name the variable food quality. And if these 3 areas were also part of our indicators, the trash receptacles, the surface areas, and the floors, and again, if scores on the trash receptacles, cleanliness was high, surface areas were high, floors were high, these would vary together. But these 3 wouldn't really go with these 3. Like you could have a very, very clean restaurant with very poor food quality. And so these would factor out as independent factors on a statistical test. And so when you're looking at, say you're looking at getting a tool for your dependent variable, and you're going to an article, which is what you'll want to do, which says that this is how they validated the scale. This is what they did. They used a factor analysis, but instead of having things like trash receptacles, surface areas, and floors, they would have statements like, I tend to feel good about myself, and I like myself, and I'm happy with the way I am. And maybe those 3 items would go together to form a factor called self-worth or something like that. So here is an example of what this looks like statistically. And you'll remember from our correlation that higher numbers are stronger and that the highest number possible for a correlation is 1. And so these numbers of 6 are showing that, okay, this is the way these 4 items kind of clustered together. And all these other correlations for these 4 items, they just didn't fall together. They weren't high on item 2, they weren't high on item 3, they weren't high on item 4. And so the researcher might say that these 4 items on the questionnaire number 17, I know who can answer my questions on my unemployment benefit. Number 16, I've been told clearly how my application process will continue. Variable 13, it's easy to find information regarding my employment benefit. And variable 2, I received clear information about my unemployment benefit. Those four went together. High scores on one tended to go along with higher scores on the other. It's the first component, it's a strong component, and the researchers would want to give it a name, and maybe they would call it information provision. You can see this item in red also has high scores on item 1, but it's problematic because it also has kind of a high score on component 3. And so this suggests that maybe this isn't a super good item to leave in here if we're trying to measure this construct of information provision. So the item, it's clear to me what my rights are, is a little bit messy. And then we have this item, I feel I'm taken seriously, which goes pretty strongly with this cluster of items, some of them which have more than one relationship. So this might be a problem too. And so then we can see that, for example, people who scored positively on clients' privacy is taken into account tended to score negatively on the third component. So this is the kind of thing they're doing. You can see this last factor is the agreements with me are followed through. My contact person does what she or he promises, and I have clear agreements about the remaining procedures. So you can see these last items might measure a construct of like how dependable the scores are. So factor 1, maybe information availability. Factor 2, maybe client respect. And factor 3, follow through. And so the researcher would decide what to do with these items and would probably trim some of these items out to get more clear indicators of the constructs. So here's an example. This is actually my own study. And we validated a scale about meditation. And we were looking at whether early experiences matter. Development of an early meditation hindrance scale linked to novice meditators' intention to persist. And this was, we got the original paradigm from ancient kinds of texts, very old texts in Buddhist tradition, in which there was talk about hindrances, particular known hindrances that block people's meditation experiences, and we thought that we would quantify these and see if we could measure these in hopes that our researchers might, meditation teachers might be able to proactively address the main hindrances that people are dealing with. So that's what we did, and this got published. So this is the chart that we find in the components that emerged in our data and how we had to tailor it down. So what you can see here, so this is not the one that was published in the paper, I don't believe. This is the one that was from the data that I pulled up for this course. But you can see the first component was really strong with relationships in 0.7 to almost up to 0.9. And it relates to thinking during meditation. So you can see my meditation was constantly interrupted by thoughts. My brain just keeps thinking and thinking no matter what I try. Worries or negative emotion keeps surfacing. When meditating, I thought of other things I'd rather be doing. So that was our first component. The second component seemed to suggest that meditation wasn't for them. It was a special thing for other people. And you can see how we clustered these together. Meditation can't change a person's brain. I don't think I will ever be able to meditate well. Meditation might be possible for others, but not for me. So kind of a fatalistic view. The next one, these dark numbers in the 6.6 and 0.7, stronger correlations, was sort of an optimism. I know that meditation will become easier. I was able to refocus on my breathing when I found my mind wandering, and so forth. And then our last component was related to physical discomfort. And the scale that we ended up with this is the one from the paper, it had these clusters. And so this is what we published in final. So we kept those first ones that seemed to relate to this hopelessness. We kept the second cluster after we narrowed it down and ran the test again. We kept the second cluster about thoughts, and we kept the third cluster about this sort of optimism. This last column just relates to an additional factor analysis that one does to double check the items using a different technique. And so that's how these things would work. Lastly, we'll talk about regression. So regression is a tool for actually predicting something based on these correlations. So regression is a technique that allows researchers to make predictions about one variable based on levels of one or more other variables. So once we know there's a correlation among a number of variables, then we assign one or more variables as predictors and another as outcomes. We call it the Y variable. So for example, if there's a correlation between people's high school grade point average and their college grade point average, we can use students' high school grade point average to predict their college grade point average. And one thing we have to be careful to always remember about correlations is that we can't perfectly predict for any individual. All we can do is predict likelihoods, like it's likely that this person with a high school grade point average will also have a high college grade point average, but it's certainly not definite. So this looks like a tough formula to remember. This is actually a slightly simplified version of the formula, but why? This is what we're predicting. So in this case, we're predicting college grade point average. So college grade point average equals B for variable 1, and B is just the slope of the line, or how much the college grade point average changes for each unit change in the high school grade point average. So for each point that high school grade point average goes up, how much does college grade point average go up? So that's the slope, and then X is just a person's score. So if we take this weight, this beta weight, and we multiply it times a person's score, we'll be able to have what their college grade point average would be. Now we're forgetting an error term here because this is going to be very imperfect, and that's also part of the formula, but this is a simple way of looking at it. So that was regression using just one predictor, but we also have multiple regression using many variables to predict a single outcome. So if we wanted to know a person's likelihood of achieving a strong GPA during their bachelor program, we can include all the variables that correlate with college GPA, like we might include high school grade point average, we might include ACT scores, we might include motivation levels. There could be a number of variables that we could think of that might help us to predict someone's college grade point average. And why might we want to do this? Colleges actually use this all the time. They predict, especially competitive colleges who have only so many slots to admit students. They want to use these regression models to predict who's most likely to succeed. And your graduate school will undoubtedly have an algorithm, a model like this to predict if you apply for grad school, how likely are you to persist and finish your graduate degree. So it's the same formula. This is, again, that simplified version of the formula, but why college grade point average is equal to the slope of the first variable we enter times that score. So maybe the slope of high school grade point average times high school grade point average. We would add to that the slope for the next variable, let's say the ACT test. So as the ACT points go up, how much does college grade point average grow up? And then we'd use a person's individual score. So what we're doing is we're taking all the correlations that we found for large groups of people who have gone to college. And from those people, we can develop a formula based on those correlations and partial correlations. And those formulas, we can then plug that formula into an individual who's applying for college. So the X is representing an individual score. And we can just continue adding all those up, add each one its beta weight times the score and add them all together, and we can predict someone's college grade point average. Not perfectly, just the odds just the odds that this person will get a grade point average according to the predictive model. So here's an example. This is from an abstract that I took out to give you an example. Variables affecting English medium instruction students' achievement. Results of a multiple regression analysis. What this study was looking at is if they were taking students in another country, I can't quite remember where right now, I think maybe Indonesia, and the students' primary language was not English, but a lot of their classes were in English, and that's what they mean by English medium instruction. And so they were looking at what variables can predict how students are going to achieve in these English medium classes. And this is a little summary of their results. English medium instruction is being used more widely for teaching content subjects at universities in non-English speaking countries. This study examined the effects of gender, prior education, socioeconomic status, English proficiency, and study load on English medium instruction students' academic achievement at a state university in Indonesia. Yes, there it is. The students' high school major, English proficiency, number of semesters, and number of courses predicted their academic grade point average. And so what that means is that of all the variables they looked at that correlated with these English medium instruction's academic achievement, these are the 4 that came out to be significant after they took out all the partial correlations. High school major, English proficiency, number of semesters, and number of courses. And this is how they presented their results. So you can see all of these lines. So these lines are showing the interrelationships among these variables. Typically, they would actually write down the weights, the correlations among and between all these variables right in this model. This model was a little bit different. And you can see that these are the factors that predicted English, but there was some overlap between these and the other factors. And in all, these variables predicted 33.8% of the variance in grade point average for students in English medium classes. So just an idea of how this is used in one study. So to summarize, complex correlations involve correlations among multiple variables. Correlation matrices are used to display correlations among multiple variables. Partial correlations we use to tease apart the correlations between 2 variables from their effect on another variable. Factor analysis uses correlations among many variables to find clusters of common factors. And regression allows researchers to predict an outcome variable from 1 or more predictors.